Okay, so A, you're given this shape. So A, you have to prove that the triangle RST, which is the big triangle, is similar to the smaller triangle of triangle PSQ, right? And also, you want to prove that PQ is parallel to RT. This is actually easy if you treat this as like, I'm going to do two problems at once because I'm going to basically prove B first, then I'm going to use B to prove A. Okay? All right. So you could do it different ways. You could do two-column proof. You can use a paragraph proof. Paragraph proof works the best. I'm going to use CER because I like CER. Okay? So claim, I will say that triangle RST is congruent to triangle PSQ, right? That's what I'm proving. So that's my claim. That's true. All right, some evidence. I set up this proportion 4 over 12 is equal to 5 over 15. I set that up, okay? But what's the point of that? Here's the explanation. Well, based on the converse of the side splitter theorem, if a line divides two triangles, if a line divides two sides of a triangle to the third side, okay, I can then say that they're parallel, right? PQ, no, this should be the parallel symbol. Sorry, this should be the parallel symbol. I'm going to fix that, right? So 4 over 12 is equal to 5 over 15, right? It's 1/3. So since the left ratio equals to right ratio, I can then say that PQ is parallel to RT, okay? If I know that, so I basically prove B using the converse of the side split theorem, then I can say angle P is congruent to angle Q and angle R is congruent to angle T because since the lines are parallel, the corresponding angles are congruent. Once I get corresponding angles, I can then say, well, if two angles of a triangle are congruent, then I know the third one, right? Because, right, triangle sum, right? The third side has to be the same. Or the property of two angles are congruent, the third side has to be congruent. Okay, since all three angles are congruent by the two angle theorem, the triangles have to be similar, right? The only thing that part I need is this was supposed to be right here. Okay, there, it's not equal, it's parallel. Okay, so let me repeat. I proved this right here, B, by using the converse of the side split theorem. Once I get the converse of the side split theorem, I can get corresponding angles, right? Since the lines are parallel, the corresponding angles are congruent. That is the corresponding angle theorem. Once I get the sides, once the angles are congruent, I know the third one is congruent by the two angle theorem. Therefore, the triangles have to be similar. There you go.